Alright, and now we go ahead with number 12, which for some reason on a specific day, the speed of cars as they pass a speed camera can be modeled by a normal distribution. What the heck is that? With a mean of blah blah blah. See? A speed of blah 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 is 2 standard deviations from the mean. Part A, find the standard deviation. Alright, so let's talk a little bit about what a normal distribution is, what a standard deviation is, and all that good stuff. See? So basically, a normal distribution talks about how your data is like, well, distributed, how it looks like, okay? And so a normal distribution looks like what they call a bell curve, okay? It looks like this. It happens a lot in real life, and it's fairly interesting. For example, if you look at the weight of all babies when they're born, and you take like, I don't know, 1,000 babies, you're gonna end up with a normal distribution, okay? If you look at like, I don't know, the height of maybe like animals or whatever in some species, you would probably end up with a normal distribution. See, and so that's why it's a normal distribution. It shows up like almost everywhere, and it's kind of cool, and it has some properties, and we're about to talk about it. So right down the middle, you will have the mean, okay? And the mean, you express it by using this symbol here. So this is the mean, okay? When they talk about standard deviations, okay, that is, think about or associate standard deviation to spread, okay? So like two spreads over, you find 75.7. So if my mean that they tell me is 67.3, that means one standard deviation over to the right and another standard deviation to the right is going to give me the 75.7. Okay? 75.7. Okay, what do I know about these 2 points right next to it? Well, I know that one next to it is going to be mean plus one standard deviation, and another one is going to be the mean plus 2 standard deviations. Okay, so that is for this guy here. ¿Vale? In other words, I can say, okay, so basically, I can have, well, I can do standard deviation plus two. I mean, sorry, one mean plus 2 standard deviations minus the mean is going to give me 2 standard deviations. See? Following this graph here. So, in other words, I'm going to have 75.7 minus 67.3 is going to give you 2 standard deviations. Okay, cool. So 75.7 minus 67.3 gives you 8.4. 8.4 equals 2 standard deviations. Divide by 2 to get standard deviation alone. Standard deviation is equal to 4.2. 4.2 what? Kilometers per hour. Okay? Oh, and that's also something I forgot to mention. When they put this negative exponent, okay, remember that a negative exponent, for example, x squared stays as x squared, x to the power of -2, okay, turns into 1 over x squared. So what does the negative exponent do? It just sort of like flips it, okay? So when you have kilometers, whoops, sorry, 1 second. So when you have kilometers, h to the power of -1, the -1 flips it, so this is the same as saying kilometers divided by h, which is the same as just saying kilometers per hour, okay? Which is what we're used to looking at. I don't know why the AB expresses it in a weird way, but whatever, okay? At least for me, it's weird. So for part A, we already did it, okay? This is part A. Just finding the standard deviation. Doop-de-doo, all fine for now. Then they tell us that speeding tickets are issued to all drivers traveling at a speed greater than 72 kilometers per hour. And we need to find the probability that a randomly selected driver who passes the speed camera receives a speeding ticket. So in other words, we need to find 72. This is what we have to do. Okay, so anyone greater than 72 kilometers per hour, what's the probability that they get caught? So where is 72 in my graph? 72 is probably like around here. See, I'm not so sure, whatever, it doesn't matter. Okay, so let's just say that this is my 72. See, so anyone traveling a speed greater than, okay, is gonna get a speeding ticket. So that means all these guys here get a speeding ticket. And we need to find the probability. See? Now, some of you might be thinking, what the hell? How are you gonna find the probability here? Okay. Ah, here's something interesting, you guys. When we talk about probability, it is going to be the area under the curve. So whatever is the area under the curve is going to be the probability of what you're looking for. So this thing I just colored in green, technically if I find the area of this figure here with the curve and everything, it's going to be the probability of someone getting caught with a speeding ticket, okay? I mean, that someone selected a random gets caught because someone selected a random is all this area here. We're about to find out how responsible or not our community is. All right? So, it's very clear what I have to do. I need to find the area under the curve. Now, some of you are probably thinking, okay, cool, how the fuck do you do that? See? Guys, the day of the test, I know I say this in every video, but damn, it's so important. You guys have no idea. The day of the test, you walk in with your pen, your pencil, 10 minutes of sleep, your brain, your graphing calculator, your formal booklet, and whatever. The motivation and everything you've learned the last 2 years. See? So really get familiar with all of those tools. What do they offer? What can you do? What can you not do? See? You gotta know that the graphing calculator has a whole ass section, and I'm dead ass on this. It has a whole ass section on distributions. See, so it can help you to calculate like area under the curve. It can help you if they give you an area and you need to find like the x values that go associated with it. You can find a lot of shit here. Okay, so where is it? It's right above vars where it says distribution in blue. So how do you hit the blue button? Well, you first hit the blue button, unironically, press vars to reach distribution. Now here are a couple tools. The only ones you're pretty much ever going to use, in my opinion, are normal PDF, CDF, and inventory normal. See? Let's talk a little bit about the intuition of each. I'm not going to go too far into it, okay? But I think it is important for you guys to know, like, just what is going on. See? So for normal PDF, the intuition I need you to have, and if I open it, see, you're gonna see it's for the probability of one x value. See, so here you put one x value. That U symbol is the mean. As I showed you here, this guy here. So that U symbol is the mean. That other symbol is the standard deviation, and paste is just enter. Okay, so for normal PDF is for finding the probability of one x value. Like if they ask you, what's the probability that a randomly selected guy drives at 50 kilometers per hour? Okay, that's this guy here. See, so that would be a context for normal PDF. Yeah, normal CDF, the one that you're gonna end up using most of the time, as we can see, kapow, kapow, kapow. See, it asks for a lower and an upper, the same mean, the same standard deviation. So this is the probability of an area, okay? So here you can see that it has negative 1 to the power of 99. Basically, what that is saying is that this is negative 1,0,0,0,0,0,0. See? You can think about it as like negative infinity, okay? So yeah, in that case, it would be saying like, okay, from negative infinity up until, I don't know, here, you find the area, okay? In this case, when you go from 72 to infinity, we're about to see how that works, see? But I do want to show you all the tools. Let me finish up with inventory normal, and I will be right with you, sir, see? So over here, inventory normal, you can see that they give you an area, okay? And you find the x value. So plug in area, get x value, okay? This is my cheat sheet. This is the very intuitive way to understand it. Whatever, see? I just hope it helps you. There it is. So in this case, we need to find the area of the stuff in green. So from 72 up until positive infinity. Okay, cool. So now I know that for CDF, or just looking around my calculator for a bit, I go ahead and remember, yeah, I use CDF because it has a lower and upper. So what is my lower? 72. From 72 up until infinity. How do you express infinity? Okay, some of you might want to get fancy and do what the calculator had, which is like 1, then like the E thing, and like 9999. Okay, sure, you can do it that way. But just think about upper being like just a very big number, okay? So go ahead and put a very big number, okay? It'll work. It'll work. It's just upper is basically infinity right now. See? You just put a huge number, it'll work, yeah? What is the mean? They gave us the mean. The mean is 67.3. The standard deviation, I got it from part A, 4.2. Go ahead and paste. There it is. See, so this area in green, this is for part B, is 0.1315. 1315. whatever, you can write the whole thing. So 1559, okay? Now, if you want to express it as a percent, you go ahead and multiply it by 100 and add a percent symbol. So it's going to be 13.15 blah 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 9%. And if you'd rather stick to significant figures, if you're that kind of guy or girl or whatever, you count 1, 2, 3, the third one. Do you round it up or down? You look at it to the one on the right. Is it 5 or above? It is 5 or above, so you round it up. You can also leave it as 13.2%, okay? Whatever, that is part B, who cares? Then they tell us that it is found that 82% of cars, so here they're giving me an area, so let's remember that area is probability, of cars on this road travel at speeds between p kilometers per hour and q kilometers per hour, where q is bigger than p. This interval includes cars traveling at a speed of 74 kilometers per hour. Show that the region of the normal distribution between p and q is not symmetrical about the mean. Okay, so this part right here is weird as fuck, okay? Basically, what they're trying to say is the following. Let me just make a little bit of space so I have more to play with and I can explain better. Yeah, so we said that the mean is 67.3, okay? So, and this part is really, really weird, so just really try to pay attention here. We need to show, with the information they gave us, that the area between P and Q is not symmetrical, see? If it were symmetrical, okay, let's first go with the case where it is symmetrical, see? So if it were symmetrical, you would have P here and Q there because, well, because we know that P is less than Q, so Q is bigger. And if it were symmetrical, you would have something like this, something like that, okay? And you would know that this is, I don't know, 15%, and therefore, if it's symmetrical, over here, it is also 15%, okay? And notice, because it says symmetrical about the mean, so like you cut down through the middle here, 15% on both sides. That is what it means when it is symmetrical about the mean. In this case, we need to show that it is not symmetrical about the mean. So it's a lot more harder to prove, but we're about to see what it means, see? So not symmetrical would be a case where it's just a little bit to the right, let's say. Let's say it's just, I don't know, this Q is maybe more over here, okay? So we would have still that same 15%, but over here I would have, I don't know, 25%. There it would not be symmetrical about the mean because one area, and this is the key idea, it's not symmetrical because one area is bigger than the other. Okay, so all you need to do is compare from the mean to like, you know, one of the edges. Okay, so compare from here to here or from here to here and work with that. Okay, now you know one key important information. See, so one key important information is that you know that the area between P and Q is 82%. Okay, so you know that whatever, I'm just gonna say P percent, okay, and Q percent. Yeah. So you know that P percent plus Q percent is 82%. Okay. And so if it were symmetrical, then that means that P percent equals half of that, so 41, and that Q percent equals half of that, which is 41% as well. See? So this is a case where it is symmetrical. See? So basically, if I find these percents of the areas under the curve from the mean to one of the edges, and they're not 41%, that is a way to prove that they're not symmetrical about the mean. If they are symmetrical about the mean, both of them should be equal. Both of them should be 81 because it's half of 82, which is the 82 that they give me. Aha, okay, now it's starting to make a little bit more sense. So what tool can I use? Well, like, do tell me key information. This interval, the 82%, includes cars traveling at a speed of 74 kilometers per hour. Now, this 74, you guys, is it bigger or smaller than the mean? Ah, bigger than the mean. See? So that means because it's bigger than the mean, we're talking about Q. Well, because Q is bigger than P, and we need to see if they're in between the mean or whatever, blah, blah. See? Okay, so technically here, you can sort of like say, okay, so this Q is like the area, but you can pretty much say that Q is going to be this 74. See? I mean, it's not that, it's hard to explain, okay? But point is, if you go ahead and plug in 74, you can draw some conclusions. Let me just pull up what the calculator says and it'll make more sense. See, this is hard to explain, but I'm trying my best. So pull up normal CDF. The lower is going to be the mean, ¿cierto? And then the upper is going to be 74, okay? Well, the mean is still 67.3. The standard deviation is still 4.2. So basically, we're saying, okay, from the mean, right, to 74, wherever it is, okay, how much is that? See? So you go ahead, you press paste, you end up with 44, okay? And so technically, if, here's the thing, here's like the big idea. If from the mean to 74 points, how much was it? 74.6, ¿cierto? No, just 74, sorry. If from the mean to 74, the area is 44%, and let's remember the total is 82% from over here, ¿cierto? From there, 82. Then the area to the left, okay, is going to be, well, this 88 minus that 40, sorry, this 82 minus the 44%, 38%. Is going to be 38%. Therefore, not symmetrical. If symmetrical, should have been 41% each. See? And that, ladies and gentlemen, is enough for you to conclude and answer part C. Okay? Now, although technically the video is over, this last part is so fucking weird, I'd rather just explain it again one more time. Okay? So again, if they're symmetrical, if these areas are symmetrical, both sides should give me 41%. Okay? The fact that I find a different area from 41, in this case 44, means that it's not symmetrical. See, it's like a little bit more to the right. See? Now, how did I know that you need to plug in 74? Well, because they tell you that this interval includes cars traveling at a speed of 74. See? And although you might tell me, okay, but you don't know if Q reaches here or there or here, well, you know at least how far it goes. You know it goes at least until 74 or more. Okay? And so if you play around with the fact that it reaches at least 74, you can go ahead and plug in 74 for normal CDF. See? So I know some of you might be thinking, again, the fact that it includes cars traveling speed of 74, like you still don't know what Q is, right? Q could technically still be 80. Okay, but just work with what they give you. They tell you that this interval includes cars traveling the speed of 74. Yeah? You know that Q reaches at least 74. Okay, so you find the area from the mean to 74, and that already makes it not symmetrical. Then that is all you need to know. Okay? That is all you need to know. So basically, think about the areas. See, if it's symmetrical, they both have to be half of 82, in this case 41. And so the moment we went over 41 by reaching 44 is the moment we said, fuck you. That is a way to show it. That is for number 12. Okay? Now, guys, if that didn't convince you, there's a lot of other methods. I'm just going to show you the answer key because why not? See, what I applied is basically this here. See, it's method 1. There's a lot of methods you can do. I think there's like 3 or 4. See? So, guys, just so you know, there's other ways to do it. For me, the most intuitive one is this one here, thinking about the areas. What is half of 82? Yada yada. See? ¿Cierto? Cool. I hope it helped. I hope more than anything you keep in mind the tools that you have. At the end of the day, that's the most important thing, guys. Don't think so much about, ooh, like, what's the trick in this exercise? What is this? What is that? Blah, blah. No, dude. Think about the tools that the exercise gives you, okay? This is an exercise that is very good for understanding normal CDF. The day of tomorrow, you're going to have to look at an exercise that helps you understand better inventory normal or normal PDF. That is why my videos, in their name, in their title at the end, in parentheses, I put like buzzwords. Cierto? I put inventory normal. Como, yo, if you want to look at inventory normal, look at this, okay? If you want to look at the normal to the curve, look at that, you know, shit like that. See? So think about the tools, think about that more than anything. And I hope it helped. That is number 12.